to begin part 2. And part 2 is just exactly the opposite of what we did last time. So, you are given, and don't forget, ln is just a logarithm, okay? It's a different notation. It's for log base e, but it's treated exactly the same as log. These two numbers are being multiplied. If I had a reason to pull this problem apart, I could write it as two separate logarithms. I'd have the log of x and the log of y, and what sign would be in between? Think about what we talked about last time. What sign would be in between there?
A plus sign.
A plus sign, very good. It would be a plus sign. Okay? So it's exactly the opposite of what we did last time. Last time we took these two and put them together. Now we're expanding. General rule of thumb, you should have a logarithm for each letter. So if you have 2 letters, you're going to have 2 logarithms when you expand. All right, so let's look at the next one. Now, I bet you know there are a couple of things we're going to have to do here, but actually the order we do it is really, really important. The first thing you should notice is this is a division. So I'm going to pull these two things apart and write log x cubed and log y to the 4th. I'm going to pull them apart. And then what sign's going to go in between them?
Minus.
Yep,
Subtract.
a subtract. Now, there's one more step. Can anybody think what that step might be?
Put the exponent in front.
Exactly. So we're going to have 3 log x out in front minus 4 log y. Whoops. Now, in case you thought about doing that first, do you see why you can't? Because the x has to have a 3 in front of it and the y has to have a 4 in front of it. So before we can pull those off, it makes sense to separate them. Would you agree? I hope so. Now, what about the next one? Logarithms do not live, radicals do not live in logarithm land. We can't have radicals in logarithm land. So what might be the first thing I do here? Guys, what's a 5th root? What power is a 5th root? Yes, it's a 1/5 power. Remember, fractional exponents are radicals, and vice versa. Radicals are fractional exponents. Now, this problem's a little different than the last one we did. If we wanted to, could we pull the 1/5 out in front right now? Yep, we sure could, and I'm going to do that. I'm going to go ahead and pull it off right now. So I have 1/5 log x over y. Now I'm going to split this, expand it. How is this going to expand? I got my 1/5. Now, what do I do with this? What's that going to look like?
X minus what?
Well, it's going to be log x minus log y. You got to keep the logarithms, but yes, it's a subtraction because that's a division. And then it's completely up to you. It doesn't really matter. You can leave it like this, or you can distribute the 1/5 if you wish. It doesn't make a bit of difference. That 1/5 can be distributed, or it can just be left out in front of the parentheses. Now, how about this one? What's the first thing you're going to do with that?
Turn x into 1/4.
Exactly. You're going to raise that to the 1/4 power. There's really no room for logarithms in, or I keep saying that, there's no room for radicals in logarithm land. We got to change them into exponents. Okay. Now, can the 1/4 come out in front? No.
No.
Because the 1/4 doesn't go with the whole fraction. So the first thing I'm going to do is expand it, split it apart. So I'll have the log of x to the 1/4 minus the log of y. It's a subtraction because that's a division. So when I expand it, it becomes a subtraction. And then you can pull the 1/4 out, but this time it only goes with the x. So there's no parentheses or anything, it's only with the x. All right, everybody with us so far? All right, how about this one? Log 100 x squared. Does the 2 go out in front? Nope, because the 2 does not go with 100. So the first thing you're going to have to do is split this. Caleb, your picture's off, so you get to tell me how this splits up.
I didn't know my picture was off.
That's okay. It's okay. How will I break this apart?
Not sure entirely.
All right, well, let's pay real close attention. This is a multiplication problem. So it'll be the log of 100 plus the log of x squared. Now, does anybody know what I can do with this guy, log x squared?
Put the exponent in front.
Yep, so it's going to be 2 log x. Now, here's the tricky part, because I kind of snuck this in on you. This actually simplifies. Remember, the base on LOG is 10, and 100 is 10 squared. So what is the log of 100? That actually reduces. What am I going to replace that with?
2 log 10.
No.
Just a 2.
Just 2, yeah. 2 plus 2 log x. The log base 10 of 10 squared is just 2. Now, Jacob, if you wrote 2 log 10, you would still have to simplify. The log base 10 of 10 to the first is 1. So either way you do it, that's just going to be 2. It's just easier to do it straight up from the beginning. The log base 10 of 10 squared is 2. Now, had this been some other number, like 90, would I have been able to simplify that? No, because 90 is not a power of 10. But since 100 is, I could simplify. We've learned a lot of stuff in the last few days, so you really need to, keep it all kind of at hand so you can deal with these things when they pop up. All right, one more. ln 30e cubed. All right, Caleb, try this one. What's step 1?
It would be the log of 30 plus the log of e to the third.
It absolutely would. Now, that simplifies. What happens when you have an ln and an e right next to each other? What always happens?
Cancel out.
They do. So this is just a 3. This is the log base e of e cubed. This is just 3 plus ln 30. If this number right here, the number in this spot, is a power of your base, then you're always going to want to simplify. All right, get your calculators out. Now we're going to do a little pressing of buttons. Super simple stuff. Here's our situation. On our calculator, I have a log button and an ln button. So in other words, if I'm going to type something into my calculator, it has to be a base 10 or a base e. Would you agree? I mean, that's the buttons I have. We can change, what I'm trying to tell you is, you're not going to be able to press your log button for this. That's a base 3. But there is a real quick way of evaluating something like this, and it's called the change of base formula. We're going to change base 3 into a base we can use. The answer to this question is simply going to be the log of 4 over the log of 3. So it's the log of this number over the log of this number. And I don't think you'll ever get those turned around or mixed up, because when you look at this expression, the 3 is kind of below, right? It's written down lower. It goes in the denominator. So this number is going to be the bottom number in the problem and in your setup. About the only thing you can do to mess this up is forget to close the parentheses around that 4. So log 4, close parentheses, divided by log 3. 10,000, how many decimal places is 10,000?
4.
Yep, thank you. That's exactly right. It's 4 decimal places. So this one's going to round off to 1.2619 if I typed it in correctly. All right, so let's look at B. B is the log base 29 of 3. Again, it's very, very simple. It's always done exactly the same way. We're going to take log 3 divided by log 29. 29 is the bottom number, so it's in the bottom. Just going to type that in. Make sure you close the parentheses around the 3. And it's 0.3263. 3263. Now, just for fun, I'd like you to try something for me. Instead of typing log 3 over log 29, would you do ln 3 over ln 29? In other words, what happens if I use natural logarithms instead of common logarithms? What happened to your answer, guys?
Stay the same.
Sure, sure. When you're changing your base from base 29, you can change it into whatever base you want. Originally, I chose base 10. Here, I chose base E. There might be weird random problems where you'd want another base, but those are the main ones because those are the buttons you have on your calculator. All right, would you finish that section for me? I'll put the answers up here. We'll check, make sure we got it. It's pretty easy. C, D, E, and F. 4 decimal places. what do you think about those? Anybody have a question about any of them? Do you match them? Hey, if you match them, give me one of those handy dandy little thumbs up deals. Uh-oh, we don't match? Which one do we not match?
I just can't solve it. I don't know.
Okay, well, I'm going to show you one more time.
Okay.
All right, so C is log base 7 of 11. So I type log 11 divided by log 7. It's the log of this number over the log of this number, top number over bottom number.
Okay.
So we type log 11, close the parentheses, and then divide by log 7. Guys, I know it's hard to pay attention, but you have to, okay?
Do you close the parentheses on both of them? Like top
Well, you
and
have to on the 11. It really doesn't matter on the 7 because you're done with the calculation at that point.
bottom? Okay, thank you.
All right, read, pay attention, please. All right, here we go. Number 4. Light intensity in Lake Superior. All right, so I've got an equation given to me. All right, and it tells me that this is the intensity and this is the depth in feet. So somebody has come up with that equation. What is the intensity at a depth of 10 feet? All right, what am I going to do?
You're gonna plug in 10 to X.
I am. Now, I need everybody paying attention because we're going to have to do some stuff that we talked about the other day. Let's see, if I times that by 10, it'll just become negative 0.125. I put in a 10 right there. Now, this is a logarithmic equation. Luckily, it only has one logarithm, so it's going to be very easy to solve. Think about a couple days ago, how did we solve these logarithmic equations? Rory?
Did you
I love my logarithms, Rory, but I don't know what you're grinning at, honey. I need you focusing. What did you say, Jacob? Sorry.
Well, do you multiply log on both sides?
Stop right there. Log log is not a number. Now, if I attach something to it, if I have like log 3, that is a number. But log by itself does not, you can't do anything with it. It's a nothing. It's 3 letters. It has to have a number attached to it in order to do anything. Now, the base on this is 10. We're going to loop-de-loop. That's how we get rid of the logarithm so that we can solve our equation. Whenever we have one logarithm in our problem, that's a very good thing, and we're going to loop-de-loop. So 10 to the negative 0.125 equals I over 12. 10 to this power equals this number. Okay, remember that from the other day? Yep, we got to make these connections, got to pull it all together here. Now, this I can type in on my calculator. Okay, so 10, use this button, raised to the negative 0.125. And you get a decimal, it's 0.7, whatever. But that isn't the answer, that's I over 12. So what are we going to have to do to get I?
Multiply 12 to both sides.
Yep, we're just going to multiply it by 12, that's right. So I ends up being, and notice I'm not doing any rounding till the end here. I'm just typing this in on my calculator, then timesing it by 12. So I get 8.9987 lumens. This is the very best scenario to have if you have a logarithmic equation. You loop-de-loop. That gets rid of the logarithm, and then you can easily solve your equation. All right, let's see what the next one says. The Richter scale. Okay, so we got another equation. Okay, so there's our equation. They give that to us. And they tell us what all these things stand for. A is amplitude, T is period, and B accounts for the weakening of the seismic wave. Words like amplitude and period are going to really come up in chapter 4. Right now, you don't know what that means, and that's okay. It doesn't really matter. We're just going to plug in numbers, right? Isn't that all we're doing for letter A? Just plugging in some numbers? So here we go. Let's plug in what we've got. A is 250. T is 2. And B is 4.25. This is easy. All I need to do is type it in. So log 125, close the parentheses. Always, if you're doing something else, you got to close those parentheses. Plus 4.25. And I got 6.3469. How's come that's a logarithmic equation? That's an equation that has a logarithm in it. How's come I didn't have to loop-de-loo on that one? Do you see what the difference is?
Because log has a number to
Exactly.
it.
And that's what I was talking about a minute ago. Log number is just, I mean, that's it. That's just the number, whatever it is. So when they say find the log of 125, okay, fine, I just type it in. Now when they say find the log of I, that's a problem. That's a problem. That's why we had to loop-de-loo to get rid of that logarithm so that we could solve for I. Yeah, that's easy. I don't see any need to do B. It's exactly the same thing. You're just plugging in numbers, so that's easy. Okay. All right, anybody have a question about that before we jump into 3.5? Which says no calculator here at the beginning, and then we'll move to a calculator later. Okay, all right, well here we go. Let's look at these exponential equations. Now, if you are not allowed to use a calculator, you can always use a calculator to find an exponent. But if you're not allowed to use a calculator, then you're going to have to get what we call a common base. Luckily, there's a very special relationship between 2 and 8. What's 8?
A cube root.
Well, it's 2 cubed. Yeah, it's 2 cubed. So you can think of this problem, and that one's so simple you may not even need to write this down, but you can certainly think of it as 2 to the x equals 2 cubed. 8 is 2 cubed. And once these two numbers match, then you can set the exponents equal. So x is clearly 3. 2 to the third is 8. And again, that one's so easy, you probably figured that out quickly. Now this is similar, except it's got this 3 out here. So let's divide by 3, get rid of that 3, and 48 divided by 3, 16. So the math that's going on here is 4 to the x equals 4 squared. 16 is 4 squared. But you probably just look at this problem and say, oh, x has to be 2. Would you agree that's pretty easy? Look at the next one. It's not quite as easy because 8 is not a power of 4, or at least an integer power of 4. So the idea is these two numbers have to match. Instead of messing around with either 4 or 8, could we break them both down and write them as powers of 2? Could we rewrite both of those, thinking of 4 as 2 squared and thinking of 8 as 2 cubed? Ollie, you still with us? Okay. Now, remember when you raise a power to a power, you multiply. So this is 2 to the 2x equals 2 cubed. Once these two numbers match, you can set the exponents equal. So the answer to that problem is 3/2. Anybody have a question so far? Okay, well, why don't you get a start on D? See what you can do with D. Now it does have a number out in front, so you'll want to take care of that number first. And if you're not using a calculator, you're going to have to make the bases match. Won't necessarily have to be 2, but you need to get them to match. Oh boy, anybody see a common base here? What do you think our common base will be?
2.
Yeah, this one's going to be 2 again, because 4 is 2 squared. So I rewrite 4 as 2 squared. And 32 is 2 to the 5th. So now multiply those exponents. This is 2 to the 4x equals 2 to the 5th. So it looks like the answer to this one is 5/4. Brag. Did anybody get that on your own? Oh, that's wonderful. Good job. A couple of you did. All right, let's look at the next one. It looks a little scary. Don't be scared. One step at a time. Problem E. What's the first thing we'll do with problem E?
Divide by 2.
Yep, so 5 to the x over 3 equals 125. Now remember, if you're not allowed to use a calculator, then you're going to have to get a common base. So somehow these two numbers have to match. What will be our common base this time?
5.
Yeah, because this side's already 5, and this side, 125, is 5 cubed. 5 times 5 times 5 is 125. Once the bases match, you can go ahead and set the exponents equal. So it looks like our answer is x equals 9. I hope you're starting to get the hang of this. Why don't you try F all by yourself, and I'll wait for someone to share an answer before I start talking. So we're going to try F all by ourselves. We talked about what to do here. If you have an answer, shout it out.
-3/2.
Yes! Wonderful. Good job. Great job. Here's how she got that. She divided by 2. And then she stood back and looked at her problem. What common base did you use?
3.
Yep. 9 is 3 squared. And 27 is 3 cubed. So we can multiply the exponents if we have double like that. So now the bases match. 2x plus 6 equals 3. She solved this little equation and got -3/2. That is wonderful. Very, very good. Anybody have a question about any of the steps of that problem? All right. 36 times 1/2 to the x over 4 equals 9. Goodness gracious. Step number 1. Oh, I'm going to call on someone here. How about Kaden Miller? What's step number 1?
That would be getting the, well, you could divide 9 by 36.
Yes, indeed. We're going to divide both sides by 36. That's exactly right. And so we're going to have 1/2 to the x over 4 equal to, now reduce your fraction. What does 9/36 reduce to? Yeah. Now at this point we need a common base. Who sees a common base?
Isn't it 1/4? Because you could take 1/2 to the 3rd, right?
1/2 is going to be your common base. That's right.
Oh.
But 1/4 is 1/2 squared. Right? 1/2 times 1/2 would be 1/4.
Yeah.
So now we have the same base. So x over 4 equals 2, and it looks like our answer is 8. Oh my, there's a bunch more here. Oh, and some of them are different. All right, let's get H and I done here and see what's happening then after that. So 27 times 1/3 to the x equals 243. This is just like what Caden had. We're going to divide by 27. So 1/3 to the x equals,
9.
is it 9? Yeah, thank you. Now this one's a little bit different. We can handle it. We got it. We need a common base. Now looking at a 1/3 and a 9, what number just seems like it should be our common base? 3? If I choose to use 3, obviously 9 is 3 squared, that's easy. What's 1/3? What power do I put here to make this a 1/3?
Negative.
Yeah, it'd have to be -1. Yep, it'd have to be a -1. Because we know that when we raise something to the negative first power, that makes it 1/. It flips it. Now, you could also use 1/3 as a common base. You could use Actually, you could use 9 as a common base. I wouldn't. I think it's easiest just to use 3. So now it looks like negative x equals 2, so x equals negative 2. All right, all by yourselves, number I, or letter I, last one in this particular grouping, like this. Go ahead and work that out. Tell me what you get. Anybody got an answer yet?
X equals 30?
Yes, good job. Well, first of all, I'm going to multiply by 8. So then I'm going to change my base to 2. So x over 5 equals 6 and x equals 30. You're exactly right. Is there anybody who doesn't understand or doesn't see where the 30 came from? Caroline? Buhner? You okay with 30?
Yeah.
All right. All right. Now the next problems, believe it or not, are exactly the same. They look different because they have these logarithms in them. So the first thing you're going to do is loop-de-loo. Well, when you loop-de-loo this equation, you get 7 to the x equals 49. So then it looks just like the ones we've been doing. Now, this is easy enough. I don't expect you to have to show any work. You can if you want, but 7 to the x is 49, so clearly x has to be 2, right? Because 7 squared is 49. This is the same thing. This is going to be 2 to the third equals x, loop-de-loo it. 2 to the third equals x, so x equals 8. Easy. Don't let this one bother you just because it's got a parentheses in there. You're going to loop-de-loo this. So 4 to the second equals x plus 2. 4 to the second equals x plus 2. So 16 equals x plus 2, and x must be 14. Same thing here. 3 to the second equals 1 minus x. Loop-de-loo. 3 to the second equals 1 minus x. So 9 equals 1 minus x. These always confuse me, so I have to be careful here. Let's see, I think I'll add the x, subtract the 9. So x equals negative 8. All right, 2 more problems, you guys, and then you don't have to hear me for a couple weeks. Aren't you joyful? Well, we got to get through 2 more. Here we go. Here we go. These look a little harder, but they're not. You know exactly what you need to do. There's this number hanging around out here in front.
You gonna make that an exponent?
Actually, you could. You actually could.
You could just divide it over.
But that would be easier. The easier option would be to just divide it over. So then you just have the log base 4 of x plus 1 equal to 2. You can go ahead and put it up here and make this x plus 1 squared, but then you're going to have a quadratic to deal with. It's probably easier to just get rid of it, period, divide. Then we can loop-de-loop, so 4 squared equals x plus 1, and it looks like x is going to equal 15. All right, our very last problem, here we go. Oh, this is a big one. Liz, what do you think we'll do first here? This is a big equation.
Divide by -3.
You can. I probably wouldn't do that first myself, but you can, as long as you remember, Liz, that you got to divide everything, each term by -3. So that would include the 6 and the 0, but it doesn't really matter. So that's okay. We can do that.
I gotta add 2 to the other side.
Yes, and I personally would have done that first. I would have subtracted 6, because then I wouldn't have to worry about remembering to divide everything, but this will work. This is going to give me exactly the same answer. So we gotta get this number moved over and this number divided out. And then we can loop-de-loop. So 6 squared equals 4 plus x. So it looks like my answer is 32, is that right? 6 squared, 36, minus 4?
Yeah.
Awesome, awesome work, people. I'll make a note that that's where we will start next time we are together. So I'll see some of you probably for the optional work. I'm going to wish you a Merry Christmas. Next time you see me, I'll be 62 because I have a birthday. So think of me on Christmas Eve. And I will see you all. Make good and safe decisions, kids, please. Make good and safe decisions. I love you, and I will see you after Christmas.
Thank you.
Bye-bye.
Thank you.
Bye.
Merry Christmas and happy birthday.
Thank you.